Yes, everyone else, this is Pluto's Posse with a special edition at the VATT, which stands for the Vatican Advanced Technology Telescope. Our friend George is down in Arizona, and he's going to give us a little bit of a background about what's going on.
Yeah, so I guess I'll just talk a little bit about where I am. So I'm in the dome of the Vatican Advanced Technology Telescope, which is up on Mount Graham in Arizona. There's a couple other telescopes up here as well, including the sub-millimeter telescope, a 10-meter radio telescope, and also the large binocular telescope, which is one of the largest optical telescopes in the world. So the VATT is actually behind me. You can only see part of it, but so kind of where I'm pointing here is the camera. The primary mirror is back here, and then there's a secondary mirror a little bit further up towards the top. And so this is kind of a little handy chart that I guess you can kind of see how the light comes through. So the light comes from stars or galaxies down, hits that primary mirror, then bounces up to a secondary mirror, and then goes through a hole in the primary to that camera down at the bottom. So let's see here, I'll hold this right here, and you can kind of compare with the telescope. So you got your primary mirror here, which is right here on the telescope, the camera here, camera there, and then the secondary is kind of up off view of the screen. So this is kind of an interesting telescope from a technology standpoint. It was designed to test a new method of making mirrors. So instead of carving out a piece of glass and kind of polishing and grinding it down till you get your mirror shape, this was made in a rotating furnace. So you load a bunch of glass into a rotating furnace, heat up the furnace and spin it up, and just like if you take a bucket of water and spin the bucket, you'll see that it bowls out. So the glass does the same thing, and if you spin the furnace at the right rate, you end up with this bowl shape, and you can then cool the glass down while it's still spinning and get yourself a nice rotating or a nice mirror made out of the glass that way. And so this was first tested with this telescope. It's a 1.8 meter mirror, so just a little shy of 6 feet or so. And that same technique has gone on to be used with telescopes like the Large Binocular Telescope, which has a set of 8.4 meter mirrors. So the technology has been demonstrated and proven and seems to be working well now.
What type of training was necessary to be able to operate the VATT?
So this telescope is pretty interesting compared to a lot of other telescopes you might use, because there's no operator here. If you go to a telescope like the ones on Kitt Peak, which are also near Tucson, or most other major research telescopes like this, there's someone who works for the observatory who essentially does all the mechanical stuff for the telescope, gets it set up in the evening and gets it ready to run, and then closes everything down in the morning. So the VATT is unique in that it doesn't have an operator. So that means that in this case I'm responsible for operating the telescope. So I had to come up 3 days early and spend the first 3 nights up here essentially learning all about the telescope. And so before I start observing, I have to do things like come up here and fill the camera with liquid nitrogen so that it stays cool enough to do the observations. And I have to set up the drives for the telescope so that we can point at galaxies on the sky. And that involves everything from kind of flipping switches up here in the dome all the way to going down to the basement and turning on oil pumps and building fans and things like that. So it's been a lot of fun, very hands-on, and I feel like you get to know the telescope a lot better than you would otherwise. So, the first 3 days were interesting though, because we had some excitement in it, so we were running around chasing, finding circuit breakers that had tripped and things like that. And so it was a good experience, nice and adventurous. So.
What have you been observing at the VATT?
My observations have been primarily of merging galaxies. So I'm looking at the starlight in these galaxies that are colliding and trying to figure out essentially where the stars are and how they're being pulled off from the galaxies by the gravitational interaction. So I've been basically staring at these galaxies for a long period of time, kind of 8 hours per galaxy, to really see the faint structure in them. And the idea is to combine that with observations of hydrogen gas and eventually do simulations of the galaxy mergers. So that's kind of the main observing plan. I've had a few fun side projects that have popped in. There was a trans-Neptunian object occultation which was supposed to happen, I guess, 3 or 4 days ago. And so this is when a trans-Neptunian object is kind of an icy solar system body, for example, kind of like Pluto. And so in this case, one of these TNOs was supposed to pass in front of a star. And as it passes in front of the star, it blocks some of the light from the star, so the star gets a little bit fainter, as seen from Earth. So you can learn about the trans-Neptunian object, its size, and things like that by looking at how much light it blocks. So that was one thing we tried to do. Unfortunately, it didn't work out. It was a little too low in the sky, but it would have been cool to do that.
Has weather hampered your observations of the VATT?
Oh yes, as far as whether or not the telescope run has been successful, it's been very, very good. We've only lost about 5 or 6 hours due to weather, and over a 7-day period, that's pretty good. So have a lot of luck, have a lot of data now. Probably get about 700 megabytes of images every night. So over the course of the 7 days, I'll have a decent amount of data to work on when I get back to Charlottesville.
What other facilities have you worked at, and how do they compare to the VATT?
So I've been to a couple telescopes on Kip Peak, the 4-meter telescope Kip Peak, which is a little bit larger mirror, so it can collect a bit more light, and also the Bach 90-inch telescope. Those are both fun telescopes. Like I said, they had operators, so it was a little less hands-on for me. But they're both fun. I mean, I've never had a bad time with a telescope, so it's always good. I'm actually hoping to come back in a few months and do some observing at the Large Binocular Telescope, which will be a pretty wild experience, being a kind of a state-of-the-art, world-class research telescope. So, but yeah, I'd say they're all different. They all have their own charm. So I did enjoy all the hands-on stuff.
How does the IRM 30-meter telescope compare to the VATT?
Well, unfortunately, I can't say too much about the IRM 30-meter. This is a radio telescope in Spain, kind of optimized for wavelengths of light that are a few millimeters, as opposed to optical light, which is fractions of a micron. So unfortunately, the 30-meter, the weather was so atrocious the few days I was there that we never actually got to use the telescope. So other than the fact that the food was excellent at the IRM 30-meter, they have a cook that cooks meals for you. Other than the food being excellent, I can't say too much about the telescope itself. But hoping to go back soon. So certainly different. I mean, you're looking at different science and different aspects of galaxies. So, but yeah, the food. I highly recommend the food. So I've never had squid at a telescope before, so it's a little bit more adventurous than I would be if I was cooking for myself. So.
What's the coolest thing you've ever seen with the telescope?
Oh. I don't know, these galaxy mergers are pretty cool from the images I've been taking. Although probably the coolest thing I've ever seen, I saw one of these occultations, like I was talking about with the trans-Neptunian object. I saw one where an asteroid passed between a star and where we were. And so it's just really cool. You're looking at this star on the TV monitor, and it's constant brightness, and all of a sudden it just blinks out for a few seconds. And the star disappears, and then a few seconds later it pops back. After the asteroid continues on. So that was really cool to see something like that happen. And that's something you could do. Most any amateur could do with a small telescope. So you don't need a big telescope like the VATT to do things like that. So that's also exciting too. Things you can do with small telescopes. Here, let me point you around the outside. Whether I've encountered. Yeah. With editing data, I'm going to give you guys a view of the outside real quick. Hopefully this, so hopefully you can kind of see that a little bit. This is the view off the telescope. So we're up here on a mountain at about 10,000 feet, and unfortunately it's a little bit hazy, but there's a nice view of the valley down below. So do you ever have trouble with data? Yeah, there can be. Sometimes the data editing can be pretty tricky. Fortunately for this telescope, the observations are pretty straightforward. So the data shouldn't be too difficult to work with. When there's clouds and things like that, that makes it a bit tricky because you have to start deciding which data is good enough to keep and which good enough, or which data should be thrown away. So, but that's all part of the fun. So, but fortunately, we take lots of calibration data to try and maximize the use we get out of all the images. Here's another picture of that was taken with this telescope. Let me see if I can. Yeah, there's not quite as glary. This is a spiral galaxy NGC 2903 that was taken with the camera. So.
What is the budget at the VATT, and how are your travels funded?
So the VATT is co-run by the Vatican Observatory and Steward Observatory. Of course, the Vatican Observatory is associated with the Catholic Church, and the Steward Observatory is associated with the University of Arizona. So between those two organizations, they provide the funding for the actual operation of the telescope. And then my travel is paid for with research grants. So my advisor has applied for funding, and I've applied for funding as well. And so out of those grants, that's what pays for the travel. There's definitely been some cool places, and that's the nice thing about telescopes is they're always in exotic locations. They're up on mountains somewhere or in unique climates and geographical locations. So it's definitely a good bit of exploring to be done.
Now, George, is it difficult to operate a telescope this big?
So it's kind of interesting. This large. Unfortunately, you can't see the whole thing. But the telescope's a decent-sized telescope. But it actually, when it's all set up to run, it floats on a very thin film of oil, and the friction is so low that you can actually move the whole thing around yourself very easily. So it's not set up right now, but if I wanted to, I could turn on the oil pumps and just come up here and just kind of grab this and actually just turn it around with just giving it a gentle push. So the telescope is very well balanced, which is pretty cool to see.
From following you on Twitter, we understand that you enjoy rock climbing. How do your hobbies fit into your travels for astronomy?
They both involve mountains, so I enjoy climbing a lot, and telescopes are on mountains, but it actually hasn't worked out that I've been able to combine them both into one trip. So it's usually kept pretty busy with either the astronomy if I'm on an observing run, or kept pretty busy with the climbing if I'm on a climbing trip. So haven't had a chance to mix them both yet, but probably one day in the future. Maybe if I go back to India, I'll try and sneak up to the Himalayas or something.
What is your focus or major in school?
So right now I'm working on a PhD in astronomy. When I was an undergraduate, I was a physics major, so I did kind of general physics degree and did a little bit of astronomy research for a professor. So if you have the chance to do that when you're in college, I definitely recommend it, working with professors. I found that a lot of professors are very happy and excited to have undergraduates working with them. You can learn a lot, and they get stuff done as well. And it's a great, you can do 6-month projects and things like that, and try out a few things, try astronomy, try physics, and see what you like.
How many years of schooling does that require?
Well, so 4 years for the physics degree, and then astronomy PhDs typically take about 6 or 6.5 years. That's kind of the average. Ranges from 5 to 8 depending on how long you take. So it all kind of how fast you can get your data and how fast you can process it, and whether issues come up and how difficult the project is. So it does vary, but kind of 6.5 years after you finish your undergraduate degree. But it's not like normal school. After the PhD isn't like classes and things like that. You'll take classes for a year or two, but after that you're just doing research. So I spend all my time looking at galaxies and working on data, and so I'm not sitting in class and taking notes and doing homework and things like that. So it's like playing mostly. So just get to have fun.
What are your specific goals for the future?
Well, right now the big one is finishing my PhD, and then after that I'd like to get some, a research position at some university doing, continuing doing research on galaxies. So that's the game plan. Just kind of continue doing what I'm doing and enjoy doing it. So I'm a bit tired. We just had an all-night observing session, so we started. we opened the telescope just before 6 p.m. and then spent a few hours doing, or an hour or so doing calibration stuff, and then from about 7 o'clock until 6 a.m. taking data on galaxies, and then we finally got the telescope shut down around, I guess, 6 or 7 a.m. So we've been up all night. It's pretty fun. So
We understand that you've been observing at the VATT with Dale. Where is he?
oh, where Dale is? Dale's asleep. So Dale was a bit tired this morning, so I let him go to bed, and so he's resting. We got another night of observing tonight, so someone's got to be rested for it. I'll take a nap while he's busy running the telescope. Oh yeah, our sleep patterns are definitely off. So instead of sleeping at night, we'll go to bed at 7 or 8 in the morning and sleep until somewhere between 2 and 4 in the afternoon. Get up in the afternoon, have a nice afternoon breakfast, meander on up to the telescope and get things running. So it's a little bit of an adjustment, but it's fun. I mean, I don't know if you guys like staying up at night. I always liked staying up later than I was supposed to. So this is a nice job where I'm encouraged to stay up late. So.
Do you sleep at the top of the mountain with the telescope?
Yeah, we sleep on top of the mountain. So unfortunately, I can't really, don't have a good way of showing it, but the telescope dome is attached to a building, and the building has some bedrooms and a kitchen and the control room for the telescope. So I pretty much get out of my room and walk about 10 feet, and I'm in the control room. So I've been up here on the mountain for 10 days now, with the exception of when I went and picked up Dale from the base camp of the mountain. But yeah, so we stay up here and got a nice cozy setup. We're actually in a red squirrel refugium. There's an endangered red squirrel that lives on the mountain. So we share the mountain with this squirrel. So I haven't seen one though yet, so I'm told they're around, but I've yet to see one for myself.
What made you want to study astronomy?
Well, so I was doing this physics in college, and I decided to try working for a professor for a few months doing research, and then I was going to get work for a company for a few months and see how I liked that. And so I started out doing this research with a professor, Chris O'Day, at the Rochester Institute of Technology. And so I spent 6 months working with him on Hubble Space Telescope data. And I actually decided that was so much fun, I just skipped doing the working for a company, finished my my physics degree, and went to grad school for astronomy. So I just tried it out, and it was a lot of fun, and so I decided to keep doing it. So I never thought I would end up doing it. When you've asked me when I was in high school or something, I don't think I would have ever said astronomy. But I'm really glad I had that opportunity and found my way into it. So it's been a lot of fun.
Now, George, do you believe in aliens?
I'm not sure I believe in movie aliens, that type of aliens. It wouldn't surprise me at all, and I think it's the odds that there is some sort of life on another planet or on another star, either in our galaxy or another one. The odds of that are pretty good. It would be slightly strange if Earth was the only planet in the universe that had some form of life. You figure there's 100 billion stars in the galaxy, and there's 100 billion galaxies. So that's a lot of stars that could have planets, and even if just a small fraction of those have life, then that's a lot. So it wouldn't surprise me if there was, but I wouldn't say that they're interacting with us now. They may not be intelligent either. It could be just bacteria or something. So. Let me see if I can pull the laptop a little closer. So this is the telescope now. So if you look up at the top, there's kind of that rectangular cage, and that's holding the secondary mirror that I was talking about. So you notice the telescope's pretty small. It's not very, it's about as tall as it is wide, and so that's one of the technological things they were trying to work on when they were designing the telescope. So.
What are the most important factors in maximizing a telescope's resolution?
Well, the first is actually the size. So the larger the telescope, the smaller the detail you can see, the finer the detail. Unfortunately, it only works to a certain extent on the Earth, though, because we have the atmosphere, and so the turbulence in the atmosphere will limit how small of a detail you can see. So actually, if you were to go on the same night and look at something with this telescope with a 1.8 meter mirror, and go up to the LBT, which is up the hill, with 1.8 meter mirror, and the LBT with 8.4 meter mirrors, if you just took them, simply pointed at a star or a galaxy and figured out how fine of a detail you'd be able to see, they would actually be able to see the same level of detail. And that's just because the atmosphere limits you. Now you can do some tricks, and the LBT does this. If you have a flexible mirror, you can actually correct some of the effects of the atmosphere. And so the LBT has just gotten that working. It's called adaptive optics. And essentially you monitor what a star looks like, because it should be a point, so anything that kind of deviates from a point, then that's an effect of the atmosphere, and so you correct that out. And so with that, the Large Binocular Telescope can actually see much smaller scale detail than the VATT can. But if you don't have a flexible mirror, then you're kind of limited by the atmosphere. So, and it's essentially, if you look across a parking lot on a hot day, you see kind of the shimmering, or the distortions in the air as the hot air rises, and it's kind of a similar thing that's happening. So, well, I'm awake, I'm doing well. So if you guys have questions, you can keep on asking. So, like I said, Dale's taking a nap, so I can sleep while he's.
How long did it take to build the VATT, and how old is the facility?
I believe the VATT was finished in the mid-1990s, so I think around 1995 was when it was finished, and the actual building and telescope structure, I think, took about a year and a half. So that includes, the foundation that has to go all the way down to rock, because you want to have a stable platform so the telescope doesn't shake, and things like that. So yeah, about a year and a half or so. So plans with other telescopes. Also, actually a month from now, I'm going to be back in Arizona at a telescope called the MMT, which used to stand for Multiple Mirror Telescope, but now I think it's just MMT. And so I'll be looking at Green Pea galaxies, is what they're called. These are kind of small galaxies with kind of maybe a greenish color that are forming stars at an accelerated rate compared to normal galaxies. So that's the next big adventure, and you should. I'll be posting pictures on my website as usual from that as well. So if you're interested in following along, there'll be stuff about that. And then I'm certain I'll hopefully, like I said, be at the LBT in April or June, and maybe you guys will be interested in seeing that as well. I put some pictures online. It's an impressive telescope. Absolutely.
Can you describe the Green Pea galaxies?
Oh, the Green Pea galaxies. Unfortunately, I don't really know a whole lot about them. They were just classified as an object, I think, a couple years ago. So I think they're very small galaxies, but they're forming stars at kind of 10 or 100 stars per year. Whereas our galaxy, the Milky Way, is forming stars, 1 star a year or something like that on average. So for some reason, these Green Pea galaxies are forming stars much more rapidly. But I can maybe tell you more about that after I go do some observations of them. But that should be a fun trip as well. I've not been to the MMT yet, so it's always fun to go to.
Can you tell us a little bit about your Summit for Someone charity, like your training, the concepts, etc.?
Oh, right, the Summit for Someone climb. So yes, I'm doing a charity mountain climb through the Summit for Someone program, which raises money for big city mountaineers. Big City Mountaineers is an organization which takes kind of inner city teens and gives them an opportunity to spend a week on a backpacking trip in the outdoors in kind of a positive environment with mentoring and things like that. So I've committed to raising $4,500 for that charity to send these kids out on these wilderness trips. And as part of that, I get to go on a climb of a mountain. In this case, it's Gannett Peak in Wyoming. So I'll be training for that, and that should be fun. I don't know if it'll include stargazing. I'm sure I'll be looking at the stars if it's clear out. So.
Who's your favorite astronomer?
My favorite astronomer that's alive, or I don't know. I think my favorite astronomer is probably a guy named Jim Condon, who's a radio astronomer at NRAO in Charlottesville. So he's a real smart guy. You can ask him any question, and he'll say, oh, I don't know. He'll think about it for a second, and then he'll give you a brilliant, insightful answer into what's going on. So he's a real smart guy, and I always enjoy talking to him. So yeah, and there's a bunch of people like that. It's hard to pick just one, but certainly the people I interact with on a regular basis, he's high on the list. And of course, my advisor Aaron Evans, who's a great guy to work with, and doing cool research on emerging galaxies.
What about ancient astronomers?
You're going to test my knowledge. There's so many big names; it's hard to pick one, I guess. But certainly, Newton did some cool stuff related to astronomy, and Tycho and Kepler. All very amazing bits of work that it's the fact that they were able to accomplish so much with what technology they had at hand is pretty astounding.
Unfortunately, we are out of time.
Thanks for joining us, George.
This is Pluto's Posse signing out.
Thank you. I enjoyed it. I hope you guys had a good time. Looking forward to talking to you again soon, hopefully. So.